x, and moment in our x is equal to the stresses at point B is going to be equal to 0. Okay. Why is it equal to 0? Because it's at the centroid where y is equal to, no, it's not really at the, wait, yeah, it is at the centroid on the y direction. Okay. So this is plus by 0. Okay. And then moment about y is going to induce a tensile plus. Okay, because if I were to give you the cross-section view, yeah, I'll take this. Oh, come on. So now we are looking at element B, right? So we know that moment about x okay, so this is moment due to x. Anyway, it's equal to what? 0, okay? Because it's exactly at the centroid. And this is moment about y. Okay, that's the moment about y. And we know that this end is in tensile. Okay. So now we know that my is equal to what? 9600. Okay. So it's equal to 9600. Multiply by the x distance. So it's the thickness of the web. Okay, so we don't know the value. So thickness of the web, okay, is 7.24. So 7.24 times 10 to the power minus 3 divided by 2, right? And then we have to divide by IYY. So IYY is equal to 9.03. Okay, 9.03 times 10 to the power minus 6. Okay, so this will give us 100 power 3 divided by 100 power. So it's 18 minus 18.797 times 10 to the power 6 plus 0.724 power minus 3 divided by 2 times by 9600 divided by 9.03 power minus 6 is equal to 3.849 times 10 to the power 6. Let me do it again. 7.24 power minus 3 divided by 2 times by 9600 divided by 9.03 power minus 6. Yep. So the normal stress is equal to 8 minus 18.797 power 6 plus a 3.849 power 6 is equal to minus 14.948 times 10 to the power 6 Pascal. Okay. Yep. Okay. So now we know our normal stress. So what are we trying to do down here? So now if you were to look over here, our element B orientation changes. Okay. So now if we were to focus on element B, right? So we know that this is our Y, X, and this is our Z. So what we know now is we know that we have a compression, right? And this is equal to 14.948 times 10 to the power 6 Pascal. So the next thing we're going to do is we're going to find the shear, right? So this is shear. The intersecting plane is Z. and this is y, and this is shear yz. Different now, okay? So from here, we also know that stress x is equal to 0, normal stress x equal to 0, and normal stress y is also equal to 0. So if I were to sketch, this will be our normal stress x, and this will be our normal stress y. Okay? And both of them are equal to 0. Okay, so now we are trying to look at the shear now. Okay, so like before, I'm going to use this image. Okay, what happened? All right, I'm going to make it big. So I like to do similar. So we look at Vx first. Okay, so we look at Vx. Right. So this is our Vx. Right. And Vx is 16 times 10 power 3 Newton. Then we design our shear flow. Element of interest is element B. Right? Is it element B? Yep. So we know that the shear flow will come in. And over here is our terminal, right? So all together, we have what? T1, T2, T3, and T4. And over here, we have a T5 because you have both arrows meeting at a same point. So down here, what we can say is immediately you can observe this like the shear YZ due to Vx, okay, and element B is equal to 0 because y is equal to 0 because Qy is equal to what? 0. Okay. Remember about the terminal? Yeah, at the terminal, the shear stress is equal. So that make our life a bit easier. Okay, just a bit easier. Sometimes it's good to have a bit of good life. Then the Vy, the Vy is more not impossible, but you have to focus. It's a bit more complicated to calculate. Okay, so this is our Vy, right? So if we were to sketch our shear flow, the web control the direction. And you have to be really, really careful. So over here, this is your element B. And the first moment of area to take, right? And I'm pretty sure you'll know. So we are going to take this whole thing. And then we are going to take this whole thing. Okay. Right. So one is for the flange and the other one is for the web. Okay. So before we go on, let's look at the formula. So again, we're going to calculate our shear YZ. And this will be equal to Vy over Ixx Qx over T. And we know that our Vy is equal to 25 times 10 to the power 3 Newton. Ixx is equal to 40.8. Okay, 40.8. Did I use 40.8? I think I did. Yeah, 40. I want to be sure that I did use 40.8. No. Yep, 40.8. And the thickness, now is the thickness of the web, right? So thickness of the web is equal to 7.24. Okay, so 7.24. Right, now comes the not difficult, but a bit more work than normal. So QZ, sorry, QY is equal to QY of the flange plus by QY of the web. So this will be our width, okay, and then this over here will be our depth, okay. So if we were to look at the flange, okay, so BF is equal to 0.166 width, and then the depth is TF. Okay, so TF is equal to 11.8. Okay, so 11.8. And then the Y bar is D. So D is what? 0.205 divided by 2. And then minus 11.8 times 10 to the power minus 3 divided by 2. Okay. So that is the flange. Now web, we have to be careful. Okay. So plus, so the thickness of the web, the width, right, is 7.24. Now the depth is between here to here. So it's D divided by 2 minus by the thickness of the flange. Okay, so D divided by 2. So D is 0.205. Minus 2 divided by 2 minus by the thickness of the flange is 11.8 times 10 to the power minus 3. Okay. So I want to be 11.8 is the 11.8. Why hold on? Yeah, 11.8 is our thickness of the flange. Let me be sure. Thickness of flange 11.8. Okay. So this thickness, okay, 0.202 divided by 2 minus 11.8 times 10 to the power minus 3 is the distance from here to here. Okay, that is the distance. And then the next thing I need to do is I just need to do the same thing. Minus by 11.8 times 10 to the power minus 3 multiplied by half. Okay, because that's the distance of the centroid. So from here, this is equal to 0.205 divided by 2 minus 11.8 power minus 3 divided by 2 times by 11.8 power minus 3 times by 0.166 is equal to 189.22 times 10 to the power minus 6. Let me do it again. Yep, plus with so 0.205 divided by 2 minus 11.8 power minus 3 squared times 0.5 times by 7.24 power minus 3. So it's 29.77 or 29.78. Let me do it again. Yep, Okay, so this will be equal to 189.22 to power minus 6 plus 29.78 power minus 6 is equal to 219. Okay, so 189.22. Yep, 219. Okay. So from here we can immediately calculate our shear YZ. So Vy 219 divided by 40.8, and then the thickness is 7.24. So 25 power 3. So it's 18.535 times 10 to the power 6 Pascal. Let me do it again. Yep. Okay. So what it means, okay, if I were to take out this diagram over here, right? And I will also copy the shear flow. Right. So the shear flow is going in this direction, which correspond to this direction, which is correct. And then this will be equal to 18.535 times 10 to the power 6 Pascal. Okay. So that's how you construct your element. Down here, you no need to minus off the shear induced by Vz, because our shear Y